Hey everyone, and welcome to the first in this series on trigonometry for 5.3 mathematics in New South Wales. We're going to start with this video on trig ratios, trigonometric ratios. It's going to be a bit of a revision from year 9, but it's a pretty good place to start. So, as we already are aware, trigonometry is all about angles and side lengths of triangles and being able to use them to solve problems. So we have our little diagram here. I'll make it just a little bit bigger. There we go. And we have two triangles here. Now the thing about our trig ratios of sine, cosine and tangent, these guys are the same no matter the size of the triangle. They will work the exact same way. So if we look at our triangle there, A, B, C, we're going to have sine theta and sine theta is 3/5, so opposite over adjacent. Sine theta is opposite over adjacent, so 3/5. Cos theta is 4/5. And tan theta is 3/4. Now that's based on how our ratios work. Now if we go to that bigger triangle, let's have a look at sine theta. Well, that's going to be 6/10. And when it simplifies down, lo and behold, 3/5. Same with cos theta. Alright, it's going to be 8/10. And that's going to come out as 4/5. And then tan theta, well, it's going to be 6/8, which will come out as 3/4. So you can see that it does not matter how these ratios work or how big the triangle is. If they are similar triangles, those ratios are going to be the exact same. But the ideas will be the same. So they will always be in that sort of order. So if we have a look now at how the ratios themselves work. Here we have a right angled triangle. Here's our triangle. And there's our little right angle there in red. Now, directly across from the right angle, directly opposite that right angle, is our hypotenuse. Then we have our theta, and the opposite side there is the opposite side, and adjacent being next to theta. So remembering that adjacent means next to. Okay, so how this all fits together with our trig ratios. So we will have the sine ratio. So our sine ratio, so sine theta. Now it doesn't necessarily have to be theta. It could be an alpha or a phi or a beta. It doesn't really matter. Whatever that symbol is, we tend to use theta more often than not. Sine of theta is the opposite side over the hypotenuse. So just as we saw before, opposite over hypotenuse, okay, or O over H is one of the ways that we can write it. Our cosine ratio, okay, works pretty similarly, but cos theta this time, instead of being the opposite, it is now the adjacent side over the hypotenuse. And then the tangent ratio which doesn't use the hypotenuse at all, is going to be tan of theta is the opposite side over the adjacent side, or O over A, and down here we have A over H. Now, you may remember back to when you were first introduced to this, that you would have seen a little sort of rhymey type thing that says Sokotoa. Kind of sounds like a Hawaiian volcano to me, but Sokotoa. So S-O-H, so sine opposite hypotenuse. It should be C. Let's fix that up. C-A-H for cosine adjacent hypotenuse, and then T-O-A for tangent opposite adjacent. So one of your best ways of working is when you're working with trigonometry with the basic ratios, chuck that word up the top so that you can remember what's going on. Okay, a couple of other little bits and pieces. Alright, as we move along, if we want to find the unknown length, there. Pretty simple. We're going to choose the appropriate ratio. Choose the appropriate ratio for the relationship between the angle and the sides, and then solve the equation. And we will see in some examples how this will work. Okay, if we're going to do angles are a little bit different because angles can be measured in decimals, just like normal numbers, or it can be degrees, minutes, seconds. And we will be doing a lot in degrees, minutes, and seconds in this topic. Now, a couple of things to remember with this. We have degrees. The symbol for degrees is that little circle. Minutes is an apostrophe. And seconds is the double apostrophe. Okay. How we work it out is 1 degree. Okay, 1 degree is 60 minutes. 1 minute is 60 seconds. Okay, and that's how that all will sit. And when we are finding an angle, so to find an angle, use the inverse of the ratio. So if you were using sine to find the length, you'd use the inverse sine to find the angle. So length would be sine theta equals O over H. For the angle, we would still use sine theta, but we'd actually go sine minus 1 O over H equals theta. So we use the opposite way of doing things. We call it the inverse. Let's check out a few examples and maybe see how it works. All right. Make it a little bit bigger just to make it a bit easier to see. There we go. Okay, so we need to find the value of x. Finding the value of x, the first two are pretty straightforward. We are going to have just straightforward ratios. Here we have an adjacent side Alright, so we have adjacent and the hypotenuse. So that would mean the cosine ratio. So we go cosine of theta equals A over H. Cos of 27 degrees is going to be X over 11. So this is the step where we substitute what we know into the equation. And we multiply everything by 11 because we are solving an equation. There's no difference here in solving the equation than any other way that we would solve equations. So we end up with 11 cos 27 equals X, and then we just type that straight into our calculator. So here we have our calculator. So this is one of the new ones that we're using at school. And we just type this straight in. So we go 11 cos 27 equals. Now, we've got 9 point, is it 801? Now we do want to go to 2 decimal places. We don't want to go too much further than about there. So we will make this 9.8. We'll just go to 1 decimal place today. Let's look at the other one. We have an opposite side this time. We have an opposite side and we have the adjacent side. And no hypotenuse this time. So we're not going to use cos, we're not going to use sine, we're going to use tan. So we're going to use tan of theta equals the opposite over the adjacent. And we substitute in. Alright, so our opposite is our x, 38 is our adjacent. We do our steps for solving the equation. And it's really important that you write this out in this fashion, or at least write out the steps that you're taking so that we can see how you've gotten to your answer. So now we've got 38 tan 69 equals x. So now we need to go back to our calculator and type that one in instead. So 39 tan 69. Make sure we're closing off our brackets, hitting equals, and we're going to go 98.993. 98. I'll just fix up my 9 there. 98.993. Now this is one of those curly ones. We want to go to 1 decimal place, but we're actually going to go for the 9 here. So this 9 means that the 9 in front has to go up 1. That 9 in front going up 1 means that the 8 in front of it has to go up 1. So it's actually going to be 99.0. And that's X for that one. Let's keep pushing right along. And now we have the last 2 examples for this one. Still finding the sides. So here is going to be a little bit different. There's going to be an extra step involved. But we have the hypotenuse. And for this one, we have the opposite. So we're going to use sine. So sine theta O over H. Now, I find it really important to start there so I know in my head I'm starting in the right spot. And I've got it written down the page and I don't have to try to remember it later. Substitute what we know. Alright, this is going to be 21 over x. Now, I could step this all the way through, and in fact, I will do that for this one. For the second one here, I won't do it. I'll just do this simple trick. For this one, we're going to times everything by x, which gets us x sine 33 equals 21. That's not really going to help us because we want x on its own. So we divide by sine 33, divide the other side by sine 33, and that leaves us with x equals 21 over sine 33. So let's whack our calculator out now and do that one. So we want to go 21 over, now this is a new calculator, there we go, sine 33 equals, and there we have 38.55. 38.557 will go to 38.557. But if I round it to one decimal place, because we've got that 5 there, the next 5 up is going to go to a 6. So 38.6 is our answer. Should probably put the meters there as well. Our next one. Now for this one, I'm just going to give you a little bit of a trick. So if you notice in the first one, the second line versus the fourth line, you can see that the x and the sine 33 have simply traded places. So on this next one, that's all I'm going to do. But again, no hypotenuse. I have the adjacent and I have the opposite. So we're going to use tan. Might need to move over a little bit. There we go. Tan theta equals O over A. Substitute what we know. That's probably not going to be the best spot for it, but that's okay. 53 degrees 40 minutes equals 71.3 over x. And like I said, it's just going to swap places. That's all it's going to do. The x and the tan 5340 are just swapping places. So x equals 71.3 over tan 5340. And we're going to go and see what that looks like. So you can see there that second line and third line in this one resemble the second and fourth line in this one. Okay. So let's get to it. Let's get that calculator out. So 71.3 over tan. So 71.3 over tan. 53 DMS for degrees, minutes, seconds. 40. Actually, we might go back one. Can I go back one? There we go. Let's add in the next symbol. Equals, and you see there, it is 52.43. 52.43. So to one decimal place, it's just 52.4 centimeters. That's it. That's trig ratios. Hopefully this has been informative and helpful. Good luck with all your questions. See you in the next video.